All right, waiting for everybody to be able to get back in. Ha ha ha. Can you hear me now? I know. You look
loud and clear.
Hate it when that happens, right? Now I'll just whisper. No, don't be funny. You're not funny. There we go. And all right, hopefully that's everybody back in there. Sound better? All right, we'll keep going. Okay, thank you. Yeah, good. Fix it. Don't let us go. There was one time all term, last term, there was some weird setting. I went almost the whole class and I didn't understand chat even then. People are trying to tell me, can't hear you, can't. Anyway, that was very unfortunate. Lost most of the lesson. So you're distributing the negative. You're subtracting both of these values is kind of what this negative means. Subtracting the x and subtracting the 7. Or perhaps more easily, let's get somebody else back in here. -1 times every term inside. To answer the question, probably this person who wasn't back in.
You know, that answers my question. So would it be wrong if I were to still go about writing plus -7? I mean, either way, I'm still.
No, it wouldn't. I mean, at this point, I'm going to do it. Well,
But just so I don't get confused, it's not wrong to write it that way, just to keep track of it in my mind. Okay.
yeah, I mean, you're still going to get 7. I mean, 12 plus a -7 results in.
We can't hear you again.
I don't know why that's happening now. Now you're telling me the answer again, and I can't hear you.
Huh. Did it previously start out fine and then drop?
Well, I can hear him fine.
Yeah, it started off fine, and now it sounds like you're going back to a little bit more of a whisper.
Yeah.
Can't hear him at all.
Hey, now I can't hear him.
Not sure what to make of this, folks. Let's see. All my equipment. Wonder if it has to do with me turning around. Or am I talking softer? Am I a whisper again? Or
I can hear you a little bit better, but it's still very fairly quiet.
I do. Let's see. Let's try this.
There we go.
Is that better?
Yeah.
Okay. I switched. I have a separate camera, separate from my computer. So the camera has its built-in microphone and the computer had a built-in microphone. So I'm using the camera microphone. Is this better?
Yeah.
Right now? Okay.
Thank you.
Maybe that setting was not, maybe it changed on itself, something.
Thank you.
Don't you love those updates where they change things? All right, I think we answered that one, right? So remember to distribute your negative signs. That, you know, it's kind of that final point to make there. Okay, 1.10, I'm going to change gears. And we're moving to systems of measurement. Basically, how do we change from one kind of system to another system? And I get out the right papers. All right, here we go. So, by the way, I believe all your 1.9 homework is distributing problems. So I mentioned there were other concepts in the text in section 1.9. They won't really apply to your homework at this point. That's why I thought I could address the distributive property and then we can move on and we'll come back and I'll talk about those other ideas when they sort of apply a little more directly to what we're doing. 1.10, systems of measurement. Well, we're talking about taking something like, 30 inches, and I want to know how many feet is that, or a bunch of feet, I want to know how many miles that is, or vice versa. If I'm, got several miles I'm interested in, I want to know how many feet is that. Similarly, we can make those same kinds of conversions, length, or weight, or mass, or volume, right? Also time, right? Just from minutes to hours, those kinds of conversions between different units. And we also want to be able to go between the US system and the metric system. Don't we want to? Yeah. All right. So sometimes you can just sort of figure it out, make sense, because, oh, I'm going from a lot of little pieces to a bigger unit. So I must have to divide the little pieces to figure out how many of the bigger units, or vice versa. But we want a technique, a method that works. And so that for almost any situation. So we're basing our technique on what's called a conversion factor, a number that we multiply by that gets us from where we started to where we want to go. And for instance, let's start with 1 foot equals 12 inches. I start with easy examples. You could probably do this in your head for some of it, but I'm going to show you how this sort of technique works. And so this is an equivalency. It's saying one of these units is equal to 12 of those units. And imagine if I were to say divide both sides by 12 inches, right? If I divide by 12 inches, this turns into 1, right? If I divide by the 12 inches, this all kind of cancels. And it's saying this fraction is the same as multiplying by 1. If I did it the other way, if I divided both sides by 1 foot, so I had the 12 inches and I had the 1 foot on the bottom, here's the same relationship but upside down, right? This is saying those two, even though they look different because they're different units, it's the same as multiplying by 1. That's sort of what allows us to use this to multiply by. We're multiplying by 1. So it's okay, even though it looks weird. So let's say I've got 54 inches and I want to figure out how many feet is that. Like I said, you might figure, oh, I'm just going to divide 54 by 12. Well, that is going to be the process eventually. Here's how this technique works. I always kind of make a fraction, right? I'm going to multiply by a fraction. I make a fraction out of my starting number. That's a 1. And I like to set up, where am I trying to go? I'm trying to get to feet. I want my final answer to be in feet. Right? Inches to feet is what I'm trying to do. Inches to feet, right? Well, I'm going to now plug in one of these conversion factors that allows me to multiply this by something that gets rid of the inches and introduces the feet. And here's sort of the trick or how the technique works. There's 2 different versions, right? I always want to use the version that has my starting units on the other side of the fraction. It's like a common factor. It cancels out. So I'm going to use the one that has inches on the bottom before I even put in the numbers. Get the units set up correctly, and now you can put in the right numbers. How does this help us? If I start with inches, this is like canceling a common factor. Oh, I can divide them both by 2 or divide them both by 5. I can divide them both by inches. So the inches are going to go away and I'm left with feet, which is what I want. Well, what's the relationship? 1 foot, 12 inches. Oh, now here's the math. 54 divided by 12. Any number on top, you multiply, 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 multiply. Any number on the bottom, you divide, divide, divide. So here I have 54 divided by 12. Calculator. And I got 4.5. 4.5 feet. 54 inches is equal to 4.5 feet. This setup with your conversion factor in the correct orientation is this basic technique here. Do it again. Cleaner, hopefully. Oh, before I go too far, right? You need a list of conversion factors. What are all those different relationships? There are lots of places you can find those. Of course, they're online, it's in our text, but in MOM, if you access the 1.10 homework, right up near the top, it says there's a link to a page of conversion factors, something like this, that shows you all these different relationships that you can use. Anything that you're going to need in this section, you'll find those conversions on the conversion table. And I think a lot of the problems actually give you the appropriate conversion factor in the problem. Test problems usually do that. Here's the conversions you're going to need. Now know how to use them. Right? Let's say I've got 3.5 miles. MI for miles. We say plain M for meters. Don't try to just, try to write the right abbreviations. And I want to figure out how many feet is that? Oh, figure out how many feet in a mile, multiply. Well, that's going to be what happens eventually. But here's that technique again, put in practice. Starting with miles as a fraction. Oh, I need my conversion factor. Slow down, Steve. Need my conversion factor, right? 5,280 feet equals 1 mile. If you know that number, otherwise it's on a conversion table for you to use. So I want to make a fraction, one way or another, out of those two numbers. I'm going to multiply so that I end up with feet. I'm going to multiply by the right version of that relationship fraction. So here was my claim, same as last example. I'm going to orient it so that my starting units are on the opposite side so they cancel out. That means the feet would go on top. What are the numbers? 1 mile, 5,280 feet. Just like a common factor. If you set it up correctly, the old units cancel out and you're left with the new units that you wanted to begin with. And so now I do 5.5 times that other number. Get out that 3.5, excuse me. And lots of feet. 18,480. That's an 8. 18,480 feet. And 3.5 miles. There's my other ones. There we go. All right. Gonna keep going. All right, how about how many pounds in 4.2 tons? And funny, right, our LB for pounds, I think that's a Latin derivative. That's why we use LB for our pound abbreviation. All right, so converting my tons into pounds. I switched to mass instead of length. I'm dealing with weights now, right? Same process, 4.2 ton. I think we get to use just plain T. I don't use that one very often. And I want to end up in pounds. I need a conversion. I don't even need to know the numbers right now. I know I want to set it up so I have tons opposite, and then the pounds will be on top, whatever that relationship is. Well, pull it out on your table. 1 ton is 2,000 pounds. Maybe you know that number, right? Here's my unit set up so the tons are going to cancel and I'm left with the pounds I'm after. 1 ton, 2,000. All right, so I'm multiplying. Oh, well, 8.4 something, right? 4.2 times 2,000, 8,400. That works. I'm going to keep going. Sometimes, let's see if we get lucky here or not. How about I've got a bunch of ounces, fluid ounces, to gallons. Here I just want to, I always address this idea of ounces. We have, unfortunately, in our US system, we use ounces for both a weight measure, right? A part of a pound, 16 ounces in 1 pound for weight, but we also use ounces for volume, fluid ounces. You know, if you're baking and anyway, they're not the same kind of thing. Weight ounces and fluid ounces are just like different kinds of units. It'd be better if we had a different word. So I try to make a point of running fluid ounces. Mom problems are going to be nice to you. Make sure they're not mixing weights and volumes. I'm not trying to trick you. But if you were running into a situation on your own in the real world, you want to be sure, am I dealing with weights to weights or volumes to volumes? You want to understand that for yourself. All right, well, let's see, what conversions do I have to work with? Now I'm going to pull out that sheet I suggested to you. Let's see. And does it tell us a good volume? Yeah. Now you can find it elsewhere, but I'm going to show you how sometimes you don't have the direct conversion. Maybe you know how many ounces in a gallon, or you could look up how many ounces in a gallon. But if I'm just working off this conversion table, I might see, well, I've got gallons that goes to quarts, and I have quarts that goes to pints, and then I've got, oh, that's too much. I got pints that go to cups, and I got cups that go to ounces. That's just silly, all right? Hopefully we've had a better conversion, but I'm just gonna show you how this might work if you had to do it this way, all right? Well, I have ounces. Let's see. 8 ounces is 1 cup, all right? And 2 cups is 1 pint. And 2 pints is 1 quart. And 4 quarts is 1 gallon. We could conceivably go through 4 different conversions to get from here to there, if this was all we had to work with. I'm gonna set it up that way, and then we'll show you how, if you've got a better conversion factor, yeah, it's easier, shorter, all right? So, I gotta get some of this out of the way. I can make a chain of conversions. Here we go, I gotta move this. I've got 260 ounces. All right, well, I have a conversion. I'll just show you how the units could work. I have a conversion that takes me from ounces to cups. Gets me 1 step of the way. And then I have another one that takes me from cups to pints. Notice I'm just going to multiply a bunch of these in a row. Get this out of the way here. And then I have another one that takes me from pints to quarts. And finally, quarts to gallons. Really, you got to have a, just watch. 1 cup is 8 ounces, all right? 1 pint is 2 cups. 1 quart is 2 pints. 1 gallon is 4 quarts. Now here's this chain of conversions to get from ounces finally to gallons. My ounces will cancel, my cups will cancel, my pints will cancel, my quarts will cancel. I'm left with the gallons. Now look at all the numbers I've got. I've got 260 on top. And on the bottom, I've got 8 times 2 times 2 times 4. You can kind of just do this in your calculator in a single string. Say 260 divided by 8, divided by 2, divided by 2, divided by 4. Smaller, smaller, smaller. Or if you would prefer to multiply out, what do I have here? 16 times 8. I should think I know that one. Yeah, 128. you know, you could get yourself two separate big numbers and now do the division. All right. But really, if you've got a chain, you can really just do them in order like that in your calculator. But 260 divided by 128. I got 2.03 gallons, and I rounded. I chose, hopefully problems will tell you how many decimal places to round to. They should tell you 1 decimal place or tenths place or hundredths place, how many decimal places. This one kept going. It didn't work out exactly even. So I have 2.03 gallons. The, how to do that string of conversions like that. Time-wise, yeah. Now, if I just knew, hang on, here I go. There's no rule about, oh, that wasn't on my table, so I can't use that conversion. If you've got a legitimate conversion factor you found somewhere else, it's okay to use it. Well, we just figured out that number on the bottom was 128, wasn't it? But 1 gallon has 128 ounces in it. Oh, that would have been a one-step problem, like the earlier examples, right? Ounces per gallon. Just like that. So if you've got a nice conversion factor that gets you there more directly, go ahead and use it. That would be that same number, 2.03, blah, 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 whatever it was. All right, sometimes we change multiple units. Let's say, this would be pretty fast. Let's go, let's see if I'm gonna do, yeah, I'm gonna change. Sorry about that. Just too big. Feet per second, per, right? Per is your fraction bar, right? The word per in a rate like miles per hour, miles over hour, feet per second. So I'm going to interpret this value. I might have just spoken it first. You know, I'm traveling at, something's traveling at 50 feet per second. Still pretty good speed, right? How many miles per hour is that, right? How many miles per hour is 50 feet per second? Well, I have two different kinds of units here. I have feet that I want to convert to miles, and I have seconds that I want to convert to hours, right? We call this a rate when it's a comparison of two different kinds of units. So I have to convert both kinds of units. I can use that string of conversions to do that, or kind of do it separately. All right, get this out of the way. Well, first I need to know that 1 mile, 5,280 feet, we did that a minute ago. Now I'm going to do seconds to hours. I'm going to do it in 2 steps, all right? Seconds to minutes, and minutes to hours. We know those numbers usually, and we don't off the top of our head often know how many seconds in an hour. You know that number, you can use it. Here I go, 50 feet per second, 1 second. All right, well, I'm gonna do one or the other. You choose, am I gonna do the lengths first or I'm gonna do the times first? I'm gonna do the length first. So I wanna go from feet to miles. Just my units again. I'm gonna go from feet to miles. Feet on the opposite, that's the big deal there, right? Put what you want to cancel on the other side of the fraction. So, okay, that's going to be 1 mile, 5,280 feet. That'll get me from feet to miles. Now I can start thinking about the time conversion. Well, seconds, I'm going to turn into minutes. Seconds was on the bottom over here. So to set it up in my conversion factor, I want it on the top, and the minutes will be on the bottom. That'll get me from seconds to minutes. And then I'm going to use the one that gets me from minutes to hours. Minutes ended up on the bottom again, so there it is on top to cancel. And then hours on the bottom. And what am I left with? Miles on top and hours on the bottom. That's what we're after. Plug in the rest of these numbers, right? 1 minute is 60 seconds. 1 hour is 60 minutes. So here's that idea. I've got several numbers to multiply on the top of my fraction chain, and one number really to divide by on the bottom of my fractions. So I can, here's what I'm going to type in my calculator, right? 50 times 60 times 60 divided by 5280. That's what I'm typing into my calculator, just like that. 50, 66, yeah, there we go. 50 times 60 times 60 divided by 5280, and then finally equals, and I'll do 1 decimal point this time, 34.1, and my units, miles per hour. That's what I was converting to. 50 feet per second, I'm going 34 miles an hour, roughly. All right. So if you've got a 1-to-1, single conversion factor, that's kind of nice. You get a single step. Sometimes you need to use a chain of conversions. I really could have chosen to do this one completely separate, and then I have a new number, and then I have to do it again as a separate, I could have turned this into 3 separate little problems. Change the feet, change the miles, or change the minutes, change the hours. But if you understand the chain, it's kind of shorter. It's kind of nice that way. Okay, metric. It's the same process using the metric system. You've had to use the metric system at all. Everything's based on powers of 10, the conversions, like 1 kilometer, just the definition of kilo is 1,000. 1 kilometer is 1,000 meters. Or 1 meter equals 100 centimeters. 1 meter is 100 centimeters. So all their conversion factors in the metric system are, multiplying by powers of 10, tens, hundreds, thousands, or dividing by those powers of tens. So let's say I've got 5,430 meters, and I want to end up in kilometers. How many kilometers is that? You're probably familiar with the idea there. Kilometers is the metric system sort of standard for longer distances, like our mile. Kilometers like the miles, right? Well, I'm going to go from meters to kilometers. I'm still going to set this up so I understand what's going on. I'm going to use the kilometer. Nobody caught me here. Kilometer, kilo, 1,000. I was already thinking of that. Fix that in your notes, please. That's 1,000 meters. 1 kilometer is 1,000 meters. Sorry, I was already starting to think about the 100 over there. Glad I caught that. Don't make mistakes, Steve. They don't like that. How many kilometers, how many 1,000 meters are there in 5,430 meters? Well, so I'm going to put meters opposite and kilometers on top. The meters will cancel. 1 kilometer is 1,000 meters. I'm just dividing that number by 1,000. Do it in your calculator, or if you're really comfortable with working with the decimal points, right? Dividing by 1,000 is moving that decimal point 3 places. Dividing by 1,000. You can put it in your calculator, but that would be 5 0.43. Include the 0 if you want. Right. 5,430 kilometers, meters is 1,000. Oh, Steve, 5,430 meters is 5.430 kilometers. Having a Monday. All right. All right. And how about liters to milliliters? All right. I just want to make sure that it's presented the same way. There's actually a couple different versions of the same conversion factor, but 1 liter is 1,000 milliliters. A liter is very close to our quart size. Milliliter would be a tiny little piece of that, 1,000th of that volume. All right, 4.3 liters. Make my fraction. Multiply by the conversion factor. I want to end up in milliliters. So liters opposite, milliliters on top. 1 liter, 1,000 milliliters. I'm multiplying by 1,000. Let's move the decimal over 3 places. Do it in your calculator if you'd like, confirm. But 4.3 times 1,000, 4,300 milliliters. So if you've got the right conversion factor to use for your situation in the metric system, it's the same process. Build your fraction to multiply by, you're multiplying by the fraction, but sometimes you end up actually doing a division. If it's the bigger number, you might say is on the bottom. And then we go between the systems. Go between them. Tell you what, I did a little of both. We'll pick up with that going between systems. We're out of time today. We'll go between metric and English systems tomorrow. It's really the same process. You just need the correct conversion. How many miles in a kilometer or vice versa, to go between the 2 different systems. The other topic we'll talk about tomorrow is, I mentioned some geometry formulas. What's the area of a rectangle or the area of a circle? And then we're given numbers to plug in and do the calculation to figure out the outcome. So it's not really a whole lot of geometry. It's applying the formulas. All right, folks, sorry for the...
Do you mind if I stay after?
Okay, I can't stay real long today. I've got to be somewhere else by 11:30, but sure, we'll have time for a couple questions, all right?
Thank you.
So see you tomorrow, okay, folks?
See you tomorrow.
We'll get the computer working too. All right, folks, see you. Feel free to log out if you're going to stick around. Hi, Dana. For some reason, I can see your picture on my screen now. There's too many of you. I can't usually see you all. Yeah, feel free to stick around for a couple minutes if you want to ask questions. All right.
Have a great day.
Thank you. You too. All right. Who's first? Go ahead. Going, Kayleen? Oh, I lost you. I can't hear
I'm muted, sorry.
Is it me again?
I have a few math questions on the review, the chapter review,
Chapter review.
that I didn't quite understand.
Good for you to get started on that. Yeah.
I started last Monday.
I actually kind of meant to say that today. It's like, oh, get started on that review. Don't wait till last minute. Go ahead.
Number 11 was 3 squared minus 4, parentheses, -2. And
After the 4, I'm sorry, say again, after the 2, after the 4?
parentheses, -2.
Yes.
And then parentheses, -1, not negative, just 1.
1
So
right here.
Parentheses. Yeah, there you go.
Okay. This kind of looks like one of those b² minus 4ac things. Is that?
Yeah, so this one, I couldn't figure it out. I don't know what my answer was.
All right. Um, and so this is an order of operations problem. I have something to square. I have
Yep.
3 numbers to multiply. And here's what I'm going to suggest. So I'm going to square first, right?
Yep.
Now, these 3, let's do it. Let's leave this minus sign, okay? And I'm going to
Okay.
multiply those 3 together.
So 4 times -3?
Oh, it's multiply, right? It's not.
Yeah.
So it's just 1 times -2 is still -2. Times
Yeah.
4 is -8.
Okay.
So those are just 3 in a row multiplied. -8 times 1 is still -8.
Okay,
worked.
that helped. Cool.
Did that make sense? It's not.
Yes, that made sense.
And so this is 9 minus minus is really 9 plus 8 is 17.
So if I don't get 100% on my,
Here it comes on my test.
none on my test, no. I know I'm not going to get 100. Oh, I might, I don't know.
Aim high, aim high. Okay, go ahead, ask your question. What was that?
So if I don't get 100% or close to 80 or so, or 80 or 90, do I get docked off points?
On the test? On the
No,
test?
on the homework assignments.
Oh,
Or is it just a
first
percentage?
of all, well, homework grades, maybe there's 15 questions and you get 13 out of 15. You could do 13 divided by 15 and figure out what that percentage is for that homework assignment.
Okay.
Each homework assignment is weighed the same as every other homework assignment. So even if this one had 12 and that one had 15, they both count the same in the grade.
The same? Okay.
So each homework has its own percent grade. The review homework, the review problems, I never grade the review. Okay, they're optional that you really should do for practice. But
So what I'm doing is just my own thing.
Yeah, the review grade doesn't count for or against you.
Cool, thanks.
Okay, yeah.
Okay, and then one more thing on the homework last week, the hand-in homework.
Yeah.
I understand I missed units, but did I do the writing okay enough to make sure you read it? You can read it.
I haven't tried to look at the hand-in homework number 2 yet, if that's what you're talking about. The first week's hand-in homework.
That's what I'm talking about. The first week.
First week's. Well, I'd have let you know or made some comment about please be neater or something if I couldn't read it. I don't remember yours in particular. Okay.
I tried.
I went through 20 of
Yeah,
them. Something.
good. Well, so my mouse is not like a mouse. It's a little pad where you have to don't have buttons.
Yeah.
So.
Right. So let's see. Did you print it out and then do your homework? Write it out on the paper?
And then I did it on the computer. Yeah.
Okay. So you tried to type your answer right into the computer, huh?
No, I had to draw. With my computer, I have to draw it. I could type it too, but it was easier to draw it than type it.
I think I know what you mean. You have a sketch pad. Actually, we actually can do that in Mom here too. I could share a whiteboard and try to draw I have a touch.
Yeah.
Well, so the alternative would be for you to just do it all on separate paper. You don't have to use that worksheet. You could do it on separate paper and then take a picture and send it to me, or scan it with some app that scans. That's
so. What is exactly is required in this class? So that the homework required. So if it says optional, we don't have to do it.
Oh yes. Okay. I mean, there's things that are graded are your Mom online homework.
Okay.
The hand-in homework.
Okay.
Which is basically weekly, and the tests. Those things are graded. I think anything that's not graded, it says optional in parentheses next to it.
Okay.
Okay.
And then I have one more question, and I'm sorry, I'll let you go.
Okay.
So do you know how many questions are on the test or the
I think
quiz?
it's about 15. You get an hour, I
15?
think it's 15 questions.
Okay, that's not too bad. Are they
Try not
okay?
to be crazy. We've tried to figure out, okay, we teachers can finish it in about 12 minutes. We ought to be able 12, 15 minutes that we ought to be able to do that and give our students an hour,
Okay.
something like that.
Okay. That makes more sense. Thank you so much.
You're welcome. Sorry if I was a little foggy today, but hopefully it went out well and
Oh, it's okay.
we'll do better tomorrow.
All right.
Yeah,
Thank you.
all right. We'll see you tomorrow then.
All right. Bye.
Bye.